Ever wonder how scientists can study something you can't actually see or touch? Well, today, we're going to break down one of the most important processes in all of science, how a big abstract idea gets turned into cold, hard data.
So let's just jump right in. Think about this for a second. We hear all the time that politics is more polarized than ever. But what does that actually mean? How would you measure it? Could you give it a score from 1 to 10? It's a really tricky problem, and honestly, it gets to the very heart of how social science even works.
And you know what? It's not just polarization. We throw around words like power, corruption, democracy, or even a failed state all the time. They feel real, and we kind of know what they mean, sort of. But in reality, they're all pretty fuzzy concepts.
But here's the thing. To get from just chatting about these ideas to analyzing them scientifically, well, fuzzy just doesn't cut it. Researchers need a really systematic way to make these ideas solid and concrete. So let's walk through exactly how they do that.
All right, so our journey starts right here with these big, messy concepts and the really tough questions they bring up.
In the world of research, what we call a concept is really just a mental construct. It's an idea. I mean, you can't hold democracy in your hand, right? You can't taste power. They're just ideas we use to try and make sense of the world. So the real challenge becomes, how in the world do you study something you can't even observe directly?
Well, the very first step is all about pinning that idea down. It's a process, and it has a name: conceptualization.
This means creating what's called a conceptual definition. And no, this isn't about grabbing a dictionary. It's more like a custom, working definition that spells out exactly what properties we're going to measure, and, this is key, who or what we're measuring. Are we looking at people, states, entire countries? You have to decide.
Check this out. It's a perfect example. Instead of a vague, fuzzy idea like liberalism, we get this super specific definition. It's the extent to which individuals support increased government spending for social programs. Boom! All of a sudden, we have something that's clear, focused, and most importantly, something we can actually measure.
So we've got our clear definition. Now we need a tool to actually go out and measure it. And that brings us to the next big step: operationalization.
You can really think of this whole thing as a simple but really powerful two-step translation. First, conceptualization. You define your terms, you get super precise. Second, operationalization. You design the actual tool, maybe a survey, maybe an experiment, to measure that definition out in the real world. They're a package deal. You can't have one without the other.
So what does this actually look like? Well, say we want to measure how often people vote. We can use a survey, right? And we can take the answers someone gives us, always, sometimes, never, and then we translate them into numbers. And just like that, we've got data that we can actually start to analyze.
The end result of this whole process is something called a variable. That's the technical term for it. It's just a measurement that can have different values. And we've done it. We've successfully wrestled a big fuzzy idea into actual data we can work with.
But hold on. Not all data is created equal. Once you have it, you have to know what kind it is. It's like you need to choose the right kind of ruler for the right job.
First up is the simplest type, called the nominal level. Here, numbers are basically just names or labels. That's it. Think about a jersey number on an athlete. Number 30 isn't twice as good as number 15, right? Or if we code Democrat as 1 and Republican as 2, that doesn't mean Democrats are in first place. The numbers are just placeholders for categories.
Okay, moving up a level, we get to ordinal. Now here, the order does matter. We all know a master's degree is a higher level of education than a bachelor's, and a bachelor's is higher than a high school diploma. But, and this is the key, the gap between each of those steps isn't necessarily equal. We know the rank, but we don't know the exact distance between the ranks.
And finally, we get to the most precise levels, interval and ratio. With these, the distance between the values is equal and meaningful. So the difference between 70 and 80 degrees is the same as the difference between 30 and 40 degrees. The one tiny difference between them is that ratio variables have what we call a true zero. Think about age. 0 years old means no age. That true zero is what allows us to say a 40-year-old is literally twice as old as a 20-year-old. You can't say that about temperature, though, because 80 degrees isn't twice as hot as 40.
So we have our variable, we know what kind of ruler we're using, but how do we know if our measurement is any good? I mean, are we even measuring correctly?
Well, this all boils down to two key ideas: reliability and validity. Let's use a dartboard analogy. Reliability is just about consistency. If you throw 3 darts and they all land in the same spot, hey, that's reliable. Validity, on the other hand, is about accuracy. Are you actually hitting the bullseye? You see, you could be incredibly reliable, hitting the top left corner of the board every single time, but you're not valid. To be valid, to actually hit that bullseye, you have to be reliable.
Okay, now I want to show you a really fascinating trap that proves why all these little details matter so much. It's a common mistake called the ecological fallacy, and it's what happens when we get our unit of analysis wrong.
Get ready for this. It's a bit of a brain teaser. On the one hand, data shows that wealthier states, like California or New York, tend to vote for the Democratic Party. But on the other hand, tons of survey data shows that wealthier individuals are more likely to vote for the Republican Party. So what gives? How can both of those things be true at the same time?
The answer to the whole puzzle is in the unit of analysis. When we look at states, we're using aggregate level data. We're looking at the group as a whole. But the pattern for the group doesn't tell us what the individuals inside that group are doing. It turns out that within those wealthy states, it's often the lower and middle income voters who are driving the overall Democratic vote. So making an assumption about individuals based on group data, that is the classic ecological fallacy.
And that one paradox shows exactly why all of this matters. This careful, sometimes tedious process of measurement, it isn't just a technicality. It really is the heart of science. It's what allows us to move beyond just our assumptions and actually test our ideas about the world with real clarity.
So, I want to leave you with this. The next time you see a headline or a study or a post that makes some big claim backed by data, you are now armed with the single most important question you can possibly ask. How exactly did they measure that? Understanding the answer to that question is the key to thinking critically about all the information that's thrown at us every day.